Welcome to the dynamic learning hub of XLR at Andheri East. A prime spot conveniently located at just a 5-minute walk from LIC Andheri Metro. In our journey of over a decade, we have proudly trained over 2 lakh students. We've also been recognized by Deloitte, Silicon India, and other accreditation bodies. Experience learning like never before in our spacious and comfortable classrooms. With high-definition projectors and state-of-the-art acoustics in place, we ensure effective learning even to the farthest point in the room. The hybrid mode is a game changer as you can enjoy the benefits of a light classroom from the comfort of your home. Even if you happen to miss any classroom session, you can still attend the same session with the same trainer at the same time at your convenience, maintaining consistency in your learning progress. Wanna get started? Join us for a demo or career chat over a cup of coffee at our Andheri branch. XLR. We don't just train, we build careers.
Yes, so the collaboration with XLR was an excellent one. We conducted a Power BI workshop with Advanced Excel over a span of 3 days. The workshop was almost 12 hours long in total. Mr. Karthik, who was an amazing trainer, helped the students understand the concepts deeply. I am sure that the students will be able to apply these concepts in their careers as well as their daily lives.
The trainer, Mr. Karthik, was an excellent person where he explained in very detailed manner on how to give great insights using very complex data sets.
So it was a machine learning workshop. We learned a lot from the course and it was a great experience attending the workshop.
The trainer was very helpful. He had a hands-on approach with his teaching and it was fabulous.
This was a great experience for me. So I would absolutely love it if XLR and its team would come again to our campus and conduct more events like this.
It was a great course and it started from basics and took me to a great extent.
The experience of the workshop was really nice. The feedback from all the students was positive. They understood the concept. The workshop was also practical based with some questions. The experience with XLR was very smooth. They helped us in conducting the workshop smoothly right from the booking of the vendor and deciding the course till the distribution of certificates. In overall, this workshop was a success during our Technical Fest Atmos, and I thank XLR for being a part of it.
I was very much interested in learning digital marketing course for a very long period of time, but I don't get a proper platform. So later for my college, I get to know about XLR and I enrolled in XLR course. It was really good experience. Our course has been taken by Mayur sir, and he was very good teacher. He not only focusing on theory part, he is doing how real digital marketing works, and it was in total very good experience. I get so much of knowledge. Here they're not only focusing on study, they are also conducting different exam to test our knowledge. And as we are giving the exam, so to appreciate our work, they give certificates for the toppers, and along with the certificate they give hampers. Thank you, XLR.
Recently, I was searching for digital marketing courses online in Google, and I came across XLR, and I attended a digital marketing course which was for 15 days. My mentor Mayur helped me for attending these classes. So he is a very informative and helpful guy. In the course end, there is a exam which I topped, so I came to the XLR office in Bengaluru. This digital marketing course has helped my career and my skills to develop, and the certificate has helped my company to join. Thank you, XLR.
I came to know about this course from my college. Actually, for learning platform, this is very nice, and I learned from here ChatGPT and AI from online. Vikas is teaching for me for AI generative and ChatGPT. We are using this technology in more. And after finishing the courses, I came for collecting the certificate. I seen the classrooms and faculties. Classroom is very nice. After the completion of exam, they will give gift and certificates. Thank you, XLR, for giving these courses. I learned a lot from this. I gained the more knowledge from here. And thank you for XLR for teaching us.
Hello guys, I'm Vikram Mahajan and I'm studying in Swami Vivekananda Institute of Technology College, and I came across a training program which was mobile app development using Flutter, which was given to us by XLR Solutions. I came across this program through my college faculty who told us about this program, that it is a very good course and you should enroll in this course. So I enrolled in this course, and initially I felt really good about this course because they started everything from a very basic point of view, that even if someone who doesn't know anything about Flutter or anything about mobile app development can also learn the same way the ones who know about it are learning. So no student was left behind and everyone was given equal attention. All the doubts throughout the course were cleared. And if we had any questions also, we were like, the trainer was also ready to stay for a longer time than it was scheduled, even for the sake of doubts. So that shows how important the students are to them. So it was a really good experience with XLR's program, and by the end of the training program, I was able to develop my own application. And through the development also there was another point. So our sir taught us about how we can connect our own mobile phone to our laptop and write code in our laptop, and you can see the output in your phone. It's just really creative and interesting.
Good afternoon, faculty members. I hope my voice is audible to everyone. Okay, yeah, so we'll start for the day. Shashank sir.
Yes, ma'am, I'm there.
Good afternoon, sir. You can take over the class for
Good
the day.
afternoon. My voice is audible, right?
Yeah, it is audible.
Okay, fine. Thank you. Right. So, good afternoon, everyone, and welcome to the day 4 of our sessions. So, I'll just share my screen. So, yesterday we have started with the project on the healthcare. So heart rate prediction, sorry, heart disease prediction we have actually seen. So let us continue on that because we didn't finish that project. Then we'll go into the banking one. Let me share my screen. It's good to go. You can screen. Should be fine. Okay. Okay, right. You can see. Fine. So, I've explained about the data set and what is the business problem, what we are actually going to do, right? And we have taken the data set and we have tried to implement it, right? So that is what we have done. And in the implementation part, we have to, implement completely. For example, right from the implementation of the libraries or calling out the libraries or right from starting where, installing the libraries. So using pip install, that particular library name. For example, like, pip install numpy, pip install pandas, pip install scikit-learn, pip install keras, pip install tensorflow, and so on. So right from the calling out the libraries and going through the process, EDA process and everything, and executing and building the model, and from the after that testing the model as well. So passing an unseen data point and trying to predict whether the data what you have used and what you have trained, and after the training process, how does this model actually work in the real time? For example, if we pass an unseen data set, a data point, right? So how does that model fare? So is it really predicting if I'm, passing a certain data point? Is it really predicting correctly whether, that person has a heart attack or heart disease, or, it is simply, bluffing or, not able to predict properly? So that also is very important because, that isn't where the use of the project actually lies. So then only what we have built here, what we are what we are spending time on it, running the deep learning algorithms and application, and this is how the implementation part can be understood. And this is where we can say that yes, okay, so our I can say our project is worthwhile, and it can be implemented into the real time scenarios. So this is where we'll try to understand each and every thing which which we are supposed to do. So just going with the project one. So yesterday we have discussed this libraries part which we have called for. So I'm just skipping this part, and then reading the data set, which is the ECG data set which we have used. So there are, I think, 21 columns in that, and 20 being the input variables, or I can say independent variables. Okay, so independent or input variables, right? And we have one target variable. So obviously the target variable will be one, right? Or the predictor, right? Or which is used for prediction, or we can also say in a simple terms as a dependent variable. it is very easy to remember independent and dependent variables than different terminologies, right? So it will be very easy for each and every person to remember independent and dependent variables. So this age, weight, height, right, BP, ECG, everything, these are all independent variables, and our target will be your dependent variable. So this is what we have seen, and for the sake of understanding and for the sake of a smooth for us to understand, we have actually renamed some of the columns as well. So we have used the function data.columns, and so that also we have discussed yesterday. So how, or you can say in the day 3 session. So how we can rename here, or we can also rename at the Excel level. So there itself you can rename if you want to rename it permanently. So if you don't want to change it in the original Excel file, you can rename it here. So here, if you rename that particular columns, it will be renamed only in the Python notebook what you are using, or in the Python environment what you are using, which is the Jupyter notebook. If you rename at the Excel level and save it, so whenever you import the data set, it will be using this name only. Okay, so this is what the minor change, what actually we have done. So data.shape and data.head we have already used, and describe function also I have explained, where it gives you the count, mean, percentiles, which is the at the 25th percentile. So we also call it as quartiles also. So 25th percentile is the Q1 and 50th percentile is the Q2. So Q2 quartile also can be called as a median value, which is the central value. Okay, and 75th percentile is the Q3, which is the third quartile. Okay, so quartiles can actually be studied in statistics part. So they come under statistics, and they come under the measures of dispersion, where the standard deviation, variance, and all will be there. So range, mean deviation, quartile deviation, standard deviation, right? And all these things come under the measures of dispersion. So that is what this quartiles actually are given inside the describe function. So now coming to the tail part is just the bottom 5 observations that also we have I've gone through. And next, coming to the EDA process. For the EDA process, we try to sum all the all the missing values, right? If here I've not taken because yesterday I told you also we are not going through the data cleaning process actually. Okay, so we are not going through that, but that is the reason our data doesn't have any missing values. So this already have been a cleaned data set. So if there is, you need to clean, so we apply techniques like box plot, right? Normalization to understand and clean the data. If the data missing value percentage is very less, for example, if it is like 1%, right? So usually industry benchmark is 5%. So anything, if you have any column with missing values of 5% or lesser, you can actually remove them. So 5% is the benchmark actually. But usually, in my projects, I don't follow 5%. I don't, it's an industry benchmark, but still, I feel less than 2% is what I feel is the, because we don't know, we might be missing some useful information, since maybe, if it is a huge amount of data, maybe in lakhs and crores, then it is maybe fine. But, if you are using a, mid-range or, low end or a, low number of rows data set, so it is very difficult, even if 5% also to delete that particular observations. So it is based upon scenarios, it is based upon situations. How do we handle it and how do we process it? So here, when we actually check this part here, when we check the missing values, there are actually no missing values in any of the columns. So that is why the percentage is also around 0. So now coming to the histogram part. So as I told you, histograms are built, or you can also say it as a distribution plot. Okay, so we call it as a distribution plot as well. We have a distribution plot that also we can construct, or we can also construct a histogram. So what does this distribution plot? A distribution plot will be in the Seaborn library. and histogram will be inside the matplotlib library. So why these plots are actually used is to check the normality in the data, or whether the data is following a normal distribution or not. So for checking this, we have to use this histogram or a distribution plot. So these are the diagrams or figures to which will try make us to understand whether the data is following normal distribution or not. So now going down, since the that also we have understood that since the data, some of the data points are not following the normal distribution. So what we thought is, let us let us not break our head that much. So instead of that, we can just go to the we can create a copy of a data set where we can actually try to filter out where we have only the heart disease patients. So because we filter it out, say here you can see that the target variable is 1. So target variable is 1, indicates that the person is having a heart disease, right? So that is what which is given in the data. So in the data set. So here you can see that the target variable is 1, and that particular person has been actually taken into consideration, and we have created a copy of that original data set. Okay, and here we are again plotting the graph. Okay, so this figure size is just, it's up to you. So whatever the figure size you want, you can actually give. This is not standard, or this is not restricted. Even the number of bins you want and number of colors. Okay, so if the data set is having some 300 500 observations, we usually go with 10 to 20 bins, and you can also give the colors in the in the syntax. For example, like here, sky color, sky blue I've given for the color, and edge color is black. So the edges it is taking as black. So you can give any color, for a visualizations, which makes even more attractive to see, because that is what visualizations know. So visualizations are useful in two types. One is the simplifying the data, right, in an easier way for us to watch, or you can say to look, right? Because huge amounts of data will be put inside a graphical point of view, and it is also easy for us to understand if it is in a graphical format. So that is where the visualizations will be useful. So this is what we have done. So now going into the down part, yesterday we have also discussed about this count plot. So usually we want the data distribution to be on a equal lengths. So if it is not equal, we can use the techniques of SWOT. Okay, so this also we have discussed. So now after that, next one we went with the crosstab. So crosstab is nothing but the where we try to get the frequencies, or you can say the count of the each. For example, here you can see that for each age it will build the frequency table. So for example, how many times that particular value is repeated. For example, here you can see the 20th value is repeated only once. So frequency indicates number of times that particular value is repeated. Okay, so for example, for you can see with 58, yeah, just randomly I've picked one age. So for 58, you can see for blue is 0. So there are around 9 people in the data set which have no heart disease who are aged 58. So a simple way you can understand by this graph. That is where the data visualization comes into the picture. So even this target is actually it is showing both kinds of things. That's where we can use the cross tabulation to get the both 0 as well as 1. So 0 is a person who is not having a heart disease, and 1 is a person who is having a heart disease. Okay, so this is what we have done. So next comes the data dot correlation. Okay, sometimes you need not panic much. Sometimes the correlation values don't come up correctly here, but we can understand that how the correlation is actually. You can also give the data dot correlation function also, Heat map is basically used to show that particular colors. For example, if you can see this kind of color, right? It is negative correlation. It's around this. See, so it's a negative correlation. So when you go up the colors, so these, you cannot predict like, the color bar will be like this only. So that will not be, it's up to the compiler what colors it will actually try to give on certain situations. Okay. So this is basically a correlation plot. Heat map gives you the correlation for the variables. So correlation can be calculated. You can actually only consider the data points which are actually correlated, which we can consider. For example, maybe smoking and smoker. No, maybe not. Height and weight. Yeah. So like height and weight, you can consider the correlation. So because some of the things doesn't make. So for example, for sex or gender, you cannot construct a correlation. For example, for age and height, you can consider, right? Because both are I can say numerical values, right, or a continuous variables. So age and height, you can check the correlation. For age and weight, you can check the correlation. Okay. So sometimes heat map shows like this. Actually, these values will be filled. You can also, if you're getting like this, you can also run the code in Google Colab also and check and get the output also. Or you can just put data.correlation, which will give you the outcome. So this is one part, and going to the next part, which is the very, very important part of training the data set. So now what we are actually trying to do is we have to create two, please listen carefully. So here we have to create two variables. One is X and one is Y. Okay. So because what is X and what is Y? X is the independent variable and Y is the dependent variable. So we know that Y is a dependent variable, and what should be my Y? Y should be the target variable, correct? No, because that is what our Y is about. So our Y is nothing but the dependent variable, and that is what should be there inside the Y, right? Now, but how to give only the independent variables to the X value? So that is in where we have a small function called as data.drop. Data.drop is a very important function which should be used when you are splitting the training and testing dataset, or you can say not training and testing, sorry, to when you are splitting the variables X and Y, because X is a independent variable, Y is a dependent variable. So now what happens in the full dataset? You are dropping only the target variable for X, right? Now, if you are dropping only target from the X, what happens? It takes the other 20. So here you can see axis 1. Axis 1 indicates the column. Okay, it's very easy to remember. Axis 0 is row, axis 1 is column. Since our target variable is a column, it's not a row, correct? No? So since our target variable is a column, we have to give axis as 1, right? So sir, is it mandatory? It's not that mandatory, but it is very good to give the axis when you write the syntax, because it will easily identify where it has to go and check this target variable is. So it is like you giving the correct location of where it has to go and check, right? Now, so you give the address correctly, the person will go easily, right? So in the same way, you are giving the address as it's a column. Where it's a column, don't check in rows. So you are saying the axis is 1, so it is directly going into the columns and checking for that particular target, and it will drop that particular target. Because we are saying drop that particular target, that means consider all the other 20. You need not again write all consider these columns. No, not required. Not required. That's where Python is extremely easy to write the code. So you need not write that particular thing. You're just dropping that particular target from the independent variables, and you are giving that target variable to the y variable, which is the dependent variable. So that means now what is happening in x, there are 20 independent variables, and y, you have only one dependent variable, which is the target. So this is what our agenda is. So now next thing is basically this method is nothing but the statistical method. Now here what we try to do is, here also we are giving axis as 0. See carefully. So if you give axis as 0, that means it will check only the rows, not the columns. So for rows, we are telling that calculate the mean value, and you separate or use minus your individual values from the mean value. So why this is done is to normalize the data. This is a pure statistical method. So normalizing the data. That means basically we want the mean to be near to 0 and our standard deviation to be near to 1. So for this, what we do is we try to calculate the mean value and subtract our values from the mean value. So if we do this, you will get the mean value, the mean values will be equal to 0, because you will have positive values and negative values. So if you add positive and negative values, your, it will, according to normal distribution, it will go to 0. That is what the idea behind, normalizing the values. So next is the standard deviation. So usually the mean will be equal to 0, or the mean should be tending to 0, and the standard deviation should be tending to 1. That is according to the normal law, right? So now a standard deviation also same, calculating the standard deviation for each row wherever it is able to calculate, and then dividing each value by the standard deviation so that it is normalized, right? So now next step is going to the or you can say checking the shape of the data, right? So checking the shape of the data. Why the data shape we are checking is, before it was 333 rows and 21 columns in the x variable, correct now? Or you can say the entire data. But since we dropped that particular target from the independent variable, you can only see 20. The same thing you can also check for this also. You can type here, okay, that y dot shape. If you run the y dot shape, it will give you the shape as 333, 1, because there is only one column in y. Now let us go to the next part, which is the data will be divided into 4 parts. Now, first of all, we divided the data into two parts. First, what is the first one is the independent variable and the dependent variable, that is x and y. Now, but that is not sufficient, right? So what is required next? So what is required next is, we have to divide the data for the independent variables into training data and testing data. So that is why for x, which is the independent variable, we divide the data into x train and x test. That means train indicates the training data, test indicates the testing data. The same way for y also, we divide the y variable data into training data and the testing data. So what happens is, it will split the data into, and now coming to how much splitting it should do. Randomly, it will not do the splitting part. We know the data points are random, but how much percentage of splitting it has to do, that is what we mention here as the test size as 0.2. So in the syntax, you can either mention any one. For example, if you are saying the test size as 0.2, that means the training data, is 0.8. So 0.8 indicates it is 80%. Okay, the training data is 80% and testing data is 0.2, which is the 20%. So here you can you can mention as train underscore size as 0.8. So if you mention train underscore size as 0.8, it will consider the training data as 80% and testing data as 20%. Or if you give testing data as 20%, it automatically Python will pick that your training data is 0.8 or 80%. Okay, so this is how we are going to split. And now, at the starting, just go up here. When we have actually done this, we have taken this, right? See this model selection, right? We are using this model selection. So this model selection is what the training and yeah. So training and splitting will be used. See here, model underscore selection is the module. Okay, in that we have a function called as train underscore test underscore split. This is the common function. So if you're doing the splitting part in any other project also, you are going to use this function only, which is train underscore test underscore split. So what this does is it will split into 4 parts. Your 2 variables, which is the x and y, which is independent and dependent variable, which will be split into 4, which is x train, x test, y train, y test. Train is nothing but the training data, test is nothing but the testing data, or you can say the validation data set. Because what we do, this 80% we are going to divide, 80-20 we are going to divide, and 80% on that 80% the data will be trained, right? So how it will split into 80-20 is it will randomly take. So now for randomly taking, we have a function called as a random underscore state. Okay, so here we have mentioned 42. There's a reason for mentioning 42. So if we mention 42, that means how much ever of random sampling you do, the observations will not change. It is a random.seed function. So instead of giving that random.seed, which is generating a random variables, we can give random underscore state, which is 42. So what this will does is it will automatically generate the same kind of randomness in the selection process of the data. So now what happens is it is going to split into 80% as well as 20%. So now that selection of data points is purely by the statistical process of using the simple random sampling. Okay, so because it is randomly selecting the data points and it is segregating, you take 80% as the training data and you take 20% as the testing data. So randomly the compiler itself will do that. You need not break your head, or we need not allocate the data points. So randomly it is only doing that splitting process with 80% as well as the 20%. Now the other important process is the conversion of the data into a categorical variables. This is one big problem if you are having categorical data set or categorized data set. Okay, so here what we are actually having is we have the outcome variable, which is the training data, or I can say, sorry, what is our outcome variable, which is the target variable, correct? Now, so for the target variable, we need to convert it into a categorical, because that is what y train and y test we have given. So we are converting into a categorical variable as yes or a no, or a true or a false. Okay, so because this is not a numerical output, this is not, we are not applying a regression technique, right? We are not applying a linear regression or a multinomial, multiple regression and all. So we are not applying any regression technique. It's a categorical, or or a classifier as an output. Now here, if you see that, it is going to split the data set, right? Okay. So next comes the, once the data is actually split, just give me a minute. Yeah, so training, splitting and all we have done. Okay, right. So now the next part is, this is also very important stuff. Okay, so here I'll just put one comment here. So next we'll go to the ES function, which is the early stopping function. So early stopping is the function name And for that, we can take any variable name as ES, or whatever you like, EAS, something like that. Anything variable, you can, whatever you want, you can actually take. So what is this early stopping? So this one, about this, actually, when we have discussed, I think in day 2 we have discussed, and I told you also, when we go into the project, I will make you to understand more, because rather than just explaining some theory, it will be easy for you to understand with a practical example. Now, what is this early stopping actually is about is, it is a technique in Keras. Okay, first of all, this early stopping, maybe I'll share the document, is a Keras technique. Okay, so what this does is, it will prevent from overfitting or underfitting. Okay, so this basically provides or helps you from overfitting and underfitting. So it helps you to, the model will, stop training, right? If it identifies when there is overfitting or underfitting happening. So overfitting and underfitting we have discussed. So overfitting is nothing but the training data is performing well, right? So I'll not again write it. Yeah. So again, anyway, I'll share the document with you. So overfitting is nothing but the training data performing well, and the testing data doesn't perform well. That is what overfitting is. Underfitting is exactly opposite. The training data doesn't perform at all, and testing data also doesn't perform. So this is where the early stopping function is actually used, particularly in the neural networks. That is what makes the neural networks more, we were discussing, more than traditional machine learning algorithms, because we don't have this. We have different techniques like hyperparametric tuning and all those things that also we implement in deep learning algorithms. But it is very important for us to apply the early stopping in the code. Now, let us come to the what exactly is this, what are there in the code, right? So for example, first is the loss function. So loss is actually the difference between the predicted and actual value. So it is basically the difference between the actual and the predicted value. So how when it is training, how much of difference is there? For example, the model predicted that the person has heart attack, right? And actually he doesn't, right? So that is where the loss function takes the difference. For example, it has predicted 40 wrong cases. That is in where we have the confusion matrix to take care. Okay, so let us leave that aside for a time being. So the loss function will identify that how many of wrong predictions has been actually done. So next comes the mode. Okay, so mode is nothing but the actually we have in mode, we have three types of things, or three methods. One is the minimum, one is the maximum, and one is the auto. So for example, for if you use minimum, so when it reaches a particular minimum, when the model actually trains, and when actually it identifies the minimum value, it actually stops training, or it no longer actually monitors the loss function. So for max, it's exactly opposite. So if you give a particular max value, so it monitors the maximum. So auto, what will do is the Keras itself will monitor, right? So it will monitor on its own, and it will make the necessary changes accordingly. Okay, so that is in what the mode function is. So usually, I prefer the mode function with the minimum. Okay, when a certain threshold, because see, I don't want my model to be underperforming, right? So when I explain the next two parts, which is verbose and patience, you will understand what is this mode function which is minimum, why I have given. Because just understanding this mode as minimum, you will not, that is no use for you. You should understand the verbose as well as the patience. Okay. So now, next coming to the verbose. Verbose is nothing but the, I can, well, wait. Verbose is for triggering an alert. Alert. Yeah. So verbose is basically for triggering a alert. Okay. For example, if you give verbose as 1, that means you are asking the model if it is, underperforming, to trigger. Like, it's like an, you can actually think like, an alarm. So for example, to get up at a certain time, you put an alarm, right? So what the alarm does, uh, it will actually help you to get up at that particular time. So it will trigger, right? So the same way, when a particular threshold has been met and the model is going down, that means it will trigger an alarm, or you can say a trigger. Here there is no alarm, no, it will not sound. So it's an alert. It will tell you an alert that please check your model is underperforming, right? For that only, next thing is the patience. So patience is nothing but the epochs. Okay. So patience is the number of epochs. EPOCH. I'll tell you what is an epoch. Patience is the number of epochs before the alert is triggered. Okay. So patience is nothing but the number of epochs before the alert has been triggered. Yeah. So that means epoch is nothing but a one training cycle. Okay. So epoch is one training cycle. So it is one training cycle. So one cycle of training is what I called as an epoch. Okay. So you're saying to the compiler that please wait for 15 cycles. That is what I'm giving patience. So why to wait 15 cycles? Okay, give 5 if you don't have the patience. That's why they're calling, as a patience. That means how much of patience or patiently you will wait, right? So, 10 epochs you will wait, or you will wait for 15 epochs, or whether you'll wait for 20 epochs, right? So how many of epochs you are willing to wait before triggering an alert that the model is underperforming? So that much of thing is there in that one single line. It is an extremely important thing, and particularly when you build a neural network, early stopping function is a must. Never build a neural network without an early stopping. I never do that because I know neural networks can become too deep, or too many layers it can form. So what is this layers and all we will discuss now. So it can go too deep and it can build too many layers. So it is very difficult sometimes. It becomes more complicated or complex. So to put a break somewhere, early stopping function is actually really useful. Okay, just give me a moment. Take some water. Okay, I think you should be fine. Okay, so fine. So that is what this early stopping function is actually really useful. So this line has it's a very small line, okay, and it's a very easy code, but understanding see the number of comments I've written just for one single line. So it's a very important line. So that is what I wanted to tell. Okay. So how much of monitoring has to be done? How much of mode where to trigger an alert? For triggering that alert, how much of verbose, whether I have to trigger or not, right? If you give verbose as 0, it will not trigger an alert. 0 is for not triggering an alert. 1 is for triggering an alert. Okay. So that is what it is. So next is the patience, where how much of cycles you have to wait. Now, so once this is done, the all important building the neural network. So this is very tricky part, and we have to understand step by step process to understand the key things. Now, let's give some space for you to understand. Maybe one line I can just put. Yeah, it's easy for me to. Okay, yeah. So we'll go step by step process. So here, if you see that there is something called as a sequential approach, correct now? So now, when you give a particular thing called as sequence, right? That means you want to build a model in a sequential way. Okay, that is the first part. Now, here you can see one simple syntax. We'll go step by step of the best way that you can understand. Here you can see a function called add. Okay, you can clearly see here, see model.add, model.add, model.add till here I've given. This is, I'll tell you what this is. Okay, for these codes I've given model.add. Correct now? Model.add is a function to add a layer. Okay, to add a layer in the, and layers, what is a layer? I've shown you. Correct now? Yeah, fine. Now, here, if you can see that there is a function called as dense. Okay, so now dense is nothing but the number of neurons in that particular layer. Okay, so maybe I can start writing the comments. Okay, so add is for adding the layers, correct now? Then dense DNSC dense is for the number of neurons in that particular layer. Okay, fine now. So this 64 indicates the number of neurons in that particular layer. Okay, so you can give the neurons as a 2 multiples, right? So this is basically give this is a formula is basically 2 power n. Okay, 2 to the power of 1, 2 to the power of 2. So you can give 4, 2 to the power of 3, which is 8. Okay, 2 to the power of 4, which is 16, 2 to the power of 5 is 32, 2 to the power of 6 is 64. Or you can also give 2 to the power of 7, which is 128, 2 to the power of 8, which is 256, 2 to the power of 9 is 512, then 2 to the power of 10 is 1024. So usually maximum I have given a neuron of about 2 to the power of n, which is 2 to the power of, I've given 2 to the power of 10, as far as I remember. So maximum number of neurons, what I have given in a particular layer is about 1024, okay, which is 2 to the power of 10. So it's a mathematical formulation. Based on that, we have to give. You should not give 30. You should, right? You have to give 64. You cannot give 68, 69. So why it is? Because computer science is built on math. Okay, so it is like that. So you cannot give something which is not a multiple of 2, or I can say 2 to the power of n formula has to be followed to give the neurons in that particular layer. Okay, so this is the very important thing. I'll just do to power of n formula should be followed to give the neurons. Sorry, neurons U is missing. To give the neurons in each layer. Okay, so this should be fine. So this formula has to be followed. Okay, so neurons, this also we have discussed. So number of neurons based upon number of calculations, or because basically neurons are calculators or triggers something in your brain. The same way, each neural network has a neuron. Okay, so that is where the deep learning is about. So that and all we have discussed in the theoretical part. Now going to the next part, which is the input dimensions. So this is very easy to understand. Since we have 20 independent variables, we are giving the dimension as 20. Correct now? Because in our data set, X is the independent variable which is having 20 variables as the input, and our outcome variable or the output variable has 1. Correct now? So here we are training the data set now. First, X train. So the number of dimensions here we are giving it as 20, which is the 20 input values or 20 input columns or variables. Okay. Now, next is the next thing is the kernel, initializer. Correct now? So the usually, please remember, the kernel initializer will be normal. So normal is the same thing what you're thinking, which is the normal distribution. So that's where I was telling you, because statistics is what plays a very important role. So it follows the normal distribution, because initially we want the data to be in a normal distribution. Okay. So next is the regularizers. Okay. So here we have given 0.001. Okay. So what is this 0.001 is? It is the learning rate. Okay. So I'll just mention here, which we call it as alpha. Okay. Just mention like this, 0.001 no, is denoted by alpha, and it is the learning rate of the model. Okay, so it is basically the learning rate in the model. Now next thing is, sir, okay, all done. What is this regularizers? Initializer is fine. Okay, so initializer is normal, so which is the normal distribution. Okay, now what is this regularizer, which is the regularizers dot 12. So here regularizers are basically used to strengthen the model. Okay, so it is used to strengthen the model. Usually the regularizer is L2, which is used. Okay, so lasso, yeah, which is used. So L2 is nothing but the rich. Okay, rich regularizer. So usually we take the 12 regularizers, sorry, which we take the L2. See, why I'm saying 12, sorry. This is the L2. Okay, so this is the L2, what we have taken, this is L. Okay, so we are taking the L2 regularizer for our model, and 0.001 is the learning rate in the model. So this is what this line. Yeah, we forgot one more thing, which is the most important one. Okay, everything is important, but our activation function, right? So, we have discussed on this. So activation function is nothing but a mathematical or a statistical function. That's it. So it's a mathematical or a statistical function, which kind of okay. So now here activation function, as I told you, is nothing but a mathematical or a statistical function. Here, which kind of activation function to be used is up to us. Okay, so it is based upon the kind of data we are actually trying to use. So the most common used activation function is the ReLU. Okay, so ReLU is nothing but the rectified linear unit. Okay, so here this is what what this does is it will create a particular layer. Okay, so next comes the dropout. Okay, so we have given this dropout for everything. If you see carefully, see here for this layer, I'll put like this so that each layer code will be at one place. So easy to understand. Yeah, see now, this is one layer. This is one layer. This is one layer. This is one layer. Okay, so here I'm creating 4 layers. Okay, so now see, for each layer I've given the dropout as 0.20. Okay, so what is this dropout? Okay, so this is a simple terms. Maybe I'll put here. It should help you. Just I'll put here. Wait. So, yeah. Okay, so dropout is nothing but the neurons. I can say dropout is, yeah, maybe you can say like this. Dropping because 0.20 we have given, that means we are dropping 20% of the neurons. So dropout is dropping the 20% of the neurons. Yeah, dropping 20% of the neurons to prevent overfitting. Okay, so dropout is nothing but dropping the neurons, yeah, to prevent overfitting. So to make the model that it doesn't overfit, we try to use the dropout function. So dropout is basically okay. So basically dropout is used for each layer and the benchmark is basically 0.20. So it is again based on requirement of how the data is actually trained. Based on that, we can we can use the more dropout or we can reduce the dropout. So we can increase or decrease based upon see, you cannot tell that here I've given 64 neurons in that particular. There is no specific way of telling that I should give only 64. No, I should give 512. I should give 256. Nobody knows when they are training the data. So it is based upon the training, the accuracy. We train or we give different things and we test different things to identify what is the ideal or the best way to build a model. Okay, so it is not for example here I've given 64, doesn't mean you also give 64 and you maybe you can try 128 or you can try 32 or you can increase to 256 or 512. So you can, give multiple things and you can try multiple things also. So that is what you may check whether the accuracy of the model is actually, performing well or not also, or whether the accuracy is coming down also. So, the regularizer also you can change L1, you can change L2, you can use maybe activation function also you can check. So like that you can change. It is not like, what I've given, that is only, this only we have to implement. No, it's nothing like that. So you can try different aspects as well. So now coming to the next part, this layer also. So it's the same from what I've given here. The only thing I think I have changed is the, already we have given the input dimensions. So again, no need to mention. Okay. And the number of neurons have reduced from 64 to 32. Usually we give the higher number at the top. For example, we start with 1024, then we come down to either 512 or 256, and then we come down from 512 to 256, and again from 256 to 128, right? If we want more layers, so what if, we want some 100 layers, we want to build a very complex model. So maybe you can give 1024, 1024, 1024 any number of times, and you can build a model. So in that way, you can actually try to build. Okay. Now coming to the, here we have removed the regularizers also after the two things, and then we have changed the activation function. Usually softmax is used when there are multi-classification problem or a multi-classification which is there. Now coming to the last layer, which is we are taking the sigmoid function. So usually what happens is we start with ReLU activation function and we go to the softmax and then we have the sigmoid function. So we also have the tanh function and so on. So we have many activation functions which are, have been researched and which we have found. So next coming to the compilation. So give me a minute. I'll give you a break and then I'll take some questions also if you have. Okay. Just wanted to explain this. That's the reason I'm not taking any questions. So I'll just take your questions as well. Now after that, we have something called as compiling the model. So in the compiling of model, we already spoke now that we will use the optimizer as ADAM, right? I've told you about ADAM, adaptive momentum estimation. So this ADAM is what the optimizer we are going to use. And the loss function for the, usually the loss function for the categorical variable is nothing but the cross entropy. So if it is a regression problem, we use the mean square, right? Mean square and root mean square as the loss function. But for categorical variables or categorizers, right, or classification problem, we are going to use the cross entropy function along with the ADAM optimizers. Okay, and this will give you the summary of the data set. Okay, this is what the code is actually about. Okay, now coming down here, again I think for ADAM, yes, for ADAM also we have given the learning rate as 0.001. So this is a slow learning rate, but what happens if you give slow learning rate is the model will learn slowly or will build slowly, or it will try to learn the data set in a slow way, but it is an ideal measure. See, we want a good model to be built, correct? No, even if the compilation takes some 15 minutes, 20 minutes, or maybe it takes 2 hours. I remember doing a deep learning project where my epochs ran for around some 3 to 4 hours. So the compilation was happening, 4 hours. I have to keep my laptop on for the compilation. So that much amount of compilation occurs, or that much amount of epochs run in a deep learning project. So that is why they say you have to have a good GPU, particularly a graphic processing unit, when you are actually applying the deep learning algorithms. Because machine learning, a simple thing will be fine because it mostly doesn't use that much of GPU. But the I can say deep learning really uses or pushes your GPU so much. So that thing you have to keep it in mind. So now coming to this down part, we have the params. Params are nothing but the layers of or the how the variables are actually performing. So this part is, this kind of output is not that important for us. So what is very important for us is the training part. Okay, so we'll go to the training part, and before that, maybe any questions you have, you can ask me. So maybe we can take some questions and then go for a break and come back. Or yeah, so I think you can ask any questions. I'll just so till what we have discussed, any questions if you have, please ask me. So I think I have explained clearly. Maybe I've gone very slow also for you guys to understand. I've gone in a very slow pace. Regularization is again a concept actually. If you want me to explain in deep, again we have to go back in PPT. Actually, I have given the regularizers. I didn't touch much because it will become a little more complicated if you have to explain why do we use lasso regularizer or ridge regularizer and or a combination of both. So it is again a little bigger concept. So you can try to get things. You can try on research on that. These are very important concepts, particularly regularization. So yeah, I think I've mentioned in the PPT. So you can just go through that. That is my suggestion. If you still want me to explain, I can do that. So wait, I'll just go to the PPT. Maybe I can share the PPT also once. In deep learning, I have mentioned the regularizers. Even the activation functions and all also I've mentioned. Yeah. So maybe I can just give me a minute. It's okay. Anyway, many people would have also have doubts on that. I guess I can just I'll share that. Wait, no problem. Hardly take some 2-3 minutes. I'll explain it. No problem. Yeah. I think you can see the PPT, I guess. Yeah. So now in this PPT, what I've shared with you, there actually I've mentioned, these are what the layers in a deep learning model. And, this is how the overfitting problem, which is the underfitting or overfitting, can be identified by using the early stopping algorithm. So next is the regularization method, particularly which is actually used is the L2 regularization. There is a reason for using the L2 regularization. Here itself, I can I can actually tell you. Let me take a pen. Which yeah. See, the very important point in this regularization actually is what is this regularization first of all? Okay, so to understand this regularization, it is nothing, the word is very big. Okay, this is just giving some penalties. Simple, those who have learned operations research will understand this concept very easily. So using an artificial variable, a dummy variable. So it is exactly that kind of thing. So what happens here is we are penalizing or we are giving some penalty. So why we are giving? What is the use? Why? Why? What? Or you can say what happens if we give? So it will calculate the gradient and it will penalize that particular term and it will stop that particular variable from going to overfitting. For example, here if you see this term, you can see here W square, right? So there's a small difference between the L1 regularization, which is the lasso. Okay. So L1 is the lasso regularization and L2 is the ridge regularization, RIDGE. So what is the difference here is, here in this ridge one, we are using the formula C0 plus, you need not by heart the formula because this regularization will be done by the Python, right? It has already, have this formula embedded in it. So we need not by heart. That's why it didn't go much into formulas as well. So C0 plus lambda divided by 2n, right? And summation W square. Here, in place of this summation W square, you will have summation W. I can say mod W. That means it is converting the negative values into positive values. That is what the modulus function is actually used. Correct, no? So the modulus function is basically used to convert the negative into positive. What is happening with this is, it is converting everything into negative. Sorry, it's converting into positive. That is putting some effect on the, the weights which are added. That is in where people have, stopped using L1, which is the lasso regression, right? So this L2 actually, what it does, it squares the term. That is why if you remember, when you calculate standard deviation, the formula is xi minus x bar. Correct now? So xi minus x bar whole square divided by n. For if you are calculating for population, it is n, or for sample, it is n minus 1. So this is summation. So you take the deviation, which is xi minus x bar, and then you square the term. That is what statistics actually tells you. This is a pure statistical technique as well. So that is what the statistics tells you. So you say, take the, what happens if you are squaring a minute term, it will go even more minute. So if which will reduce the variance in the data. So what happens is, when the term is actually squared, right, it is not having much of impact on that particular variable. So now the penalty what we are actually giving on the cost function, it will, that small impact which is actually being done, whether that the this model is going to overfit. So this additional penalty one will be added, and it helps the model from overfitting. This is what the mathematical logic behind the regularization. So now, this is what the L2 regularization is. So usually L2 regularization, it uses the tan function. So tan, like, sine in the trigonometry, you would have come across tan theta, right? Sine theta, tan theta, cos theta. So it's the same tan function, but tan h is nothing but the hyperbolic function. There are, normal trigonometric functions and hyperbolic functions. So h indicates the hyperbolic function, right? So this regularization uses the tan h function, and this is the graph of how the regularization is actually applied. Okay, so dropout is basically a kind of regularization technique, which is the I can say dropout is a combination of both L1 and L2. So if you use dropout, it is even more good. But what we do, by the by seeing the code, you would have understood now. We are using the dropout also, and we are using the L2 regularization also. So we are applying both, combination of both, as well as the L2, in order to build a model in a perfect way. Let's see, whatever kind of mathematical or statistical model or a deep learning model we are applying, it doesn't matter. See, the only thing is, we want our model to be with a good accuracy, right? That means it is able to predict well on unseen data. That's it only. That is what we are concerned about. Our model should be able to predict on unseen data very clearly, or very in a beautiful manner, so that the model which we have built, we feel that yes, it's a good model what we have built. So that is in where the so this is what dropout layers and all we are going to do. So I'll just stop sharing this. So yeah, I just wanted to go back to the PPT because just a minute. Yeah, I just wanted to go back to the PPT so that because I have given that regularization in that. So it's a very important concept, because dropout and regularization, without that we cannot control we cannot control the deep learning model, because the only biggest problem when it comes to a deep learning model is the number of layers it's going to form. So that's a tricky part. So too many layers actually create more complex scenarios. Very limited layers are always good, but everything doesn't go according to our convenience when we are building a model. So you have to make that minor adjustments, and we have to go further and build a model without disturbing, or without creating a problem that accuracy doesn't be good. Because without a good accuracy on training, and training accuracy should be good, and testing accuracy also should be good, and on unseen data if we are testing also, it should be good, correct? No, without all these things, then what is the use of doing all these things? Not required. So that is where the dropout and regularization comes into the picture. So this is a little formulations and all, but that much you need not by heart any formulas to understand and all, not required. Just how the you can say, you can just remember like how it is implemented, what is the use, what is the use of implementing the regularizations and dropouts, that you can remember. That should be fine actually, I guess. So any other doubts, anybody? So you can ask me, please. So yeah. Preeti, I hope I have cleared your doubt. So anybody, anything else regarding any kind of things which we have discussed? So anything? Okay, so just take a 5-minute break. Maybe you can put, if you have any doubts, you can put it in the chat. Maybe during the break also you can put it in the chat. That's not a big deal. Maybe I can, take up once I came back. Okay. Okay, so I think we can continue. Feedback link, you will get Anjum. Feedback link and the attendance link also. You'll be getting, I think maybe around some 4:30 they'll share. Okay, so let's share my Python page. We'll go back to the code. Yeah. Okay. Now, fine. So now let us continue. Okay. Fine. So now let us continue with this. Next is the function which is model.fit. Okay. So it's a very small function which is used to fit the data. Okay. So yeah, here I've mentioned anyway, not required. So fitting the model to the training data. So this fit, and always remember, when you are giving the fit function, first you should mention which are the variables you want to fit. Okay. So we want to fit the x, which is the independent variable, and y, which is the dependent variable. Okay. So x train and y train is what we are doing the fitting. Okay. So we'll understand step by step. Okay. So next thing is the validation data, right? Obviously, if our training data or fitting data is x train and y train, our validation data will be x test and y test. So it's a simple logic, correct? No? Right. Now here, this callbacks is the ES, which we have given. I'll just go up to show you. Yes, which is the early stopping which you have given. Okay. So that which kind of callback we are doing, we have to mention here. Okay. So this part is done. Now coming back to the epochs. Epochs already we have discussed. Here I think I have mentioned also. Epoch is nothing but the training cycle or one cycle. Okay. So that is what basically epoch is. So here, how many epochs we have given? We have given 50 epochs. Correct now? So we have given 50 epochs. That means the model will run 50 cycles. So here you can see 50 epochs I have given. So it will take epoch first out of 50, then epoch 2 out of 50. So it took 9 milliseconds. MS is milliseconds. Sometimes if the data is huge, okay, so since the data is small, it took milliseconds. Don't think it will take milliseconds. So if the data is huge, it will take even a minute also to run one epoch. For example, if you give 1,000 epochs and each epoch takes 1 minute, that means you have to wait for 1,000 minutes to run the epochs. Now imagine how much of complex a deep learning model is. Okay, so it is very important, based on the size of the data. Okay, so now here there are certain things which has to be understood. First thing is nothing but the accuracy part. Okay, so for each step, how much of this accuracy? So see, we'll go in a smoother, easier way to understand. This first accuracy here indicates the training accuracy. Please always remember, don't get confused. This accuracy indicates the training accuracy 0.57, which is very less. So now see here, the training accuracy is keeping on increasing. See, from 57.35 it became 61.59 to 68, 72, 75, 87. Because it is training one cycle after the other, it is training the machine, or it is teaching the machine, right, to build how to build a model. For that, it is training the machine. So this first part of accuracy indicates the training accuracy. Here you can see one more accuracy, which is the validation accuracy. There are two kinds of accuracies here, because it is not just the training accuracy we have to see now. Even testing accuracy, for example, if the training accuracy is 95 and testing accuracy is some 40%, that means you're having an overfitting problem. We already discussed on this now. If the training accuracy is more, right, and the testing accuracy is less, it is an overfitting problem. If the training accuracy is also less and testing also less, it is an underfitting problem. So now if you see carefully, here the training accuracy is 0.57 and the testing accuracy is 0.56. So they are very similar to each other. Okay, but it is just the one cycle, because it's a first epoch's values. No, it's a first epoch. No, so you can't come to a conclusion with that. So next, beside this accuracy, you have, these are one part. You have one more thing called as a loss function. So loss function, we have seen what is a loss function. Loss is nothing but the actual minus predicted value. Okay, so here loss function, usually it will give in positive only, because it will subtract the bigger number minus the smaller number. It doesn't matter, no, if we are subtracting smaller minus bigger or bigger minus smaller. That is why what it does is it will subtract bigger minus smaller to not give you a negative value. Usually you will not get any negative values in the loss function. Okay, see here, it's all positive value. So it will apply that modulus also, you can think of. So this is for the training accuracy. This is for the training, the loss function. Okay, this is the validation accuracy, and for validation loss function. Now, just for making you to understand, I have given 50 epochs. Okay, so we will not give 50 usually for building a project. We will not give. Okay, my my experience with projects, I have run around 1000 epochs as well. Okay, so to build a project. Okay, attendance. Okay, so usually we give around 1000, at least some 500 for a small project, because we have to train the model more, no? Then only the model will learn so much, and it will, it will actually try to build in a certain way that it is ready for prediction. So that is why we give epochs of around 500 plus in order to build a model. So just for understanding, I've just given some 50 epochs. Okay, so here you can see 50 epochs, since it takes us milliseconds for me. So I have run the thing. Now at the last, it gives an accuracy function, which is the 91 point. Here you can see that the loss function is basically the, this is the training accuracy and the loss function. So training accuracy is basically around the same as the validation accuracy, and the loss function for the training also is around 27%, and for the training and for the testing loss also it's around some 27%. So they both are very similar in accuracy and the loss function. So it is actually good, and that is this accuracy, training accuracy and testing accuracy is at the higher level. So actually if you get a model around 90+%, it is actually good. To be fair, it's really good. It has built in a good way. So now coming down, you actually plot a graph. Okay, so actually by looking at this data itself, you can this accuracy and loss function and validation accuracy and loss function, you will be able to understand that whether the model is overfitting or underfitting. Okay, so if you clearly see the accuracy is around 91% for training, for testing also it's around 91%. So there is no problem of overfitting. Okay, it's very simple to understand by that. This can be confirmed by plotting a graph. So PLT is used for matplotlib, and we plot a graph for the training and the testing accuracy. Okay, So title is nothing but the title what we put. So model accuracy title we have put, and Y label is nothing but the Y-axis name, and X label is nothing but the X-axis name, and legend is for showing what is, if you give legend, what happens is it will create how many of legends what you want. You can also give legend at the top, bottom, right, left, whatever you want. So it will show you the differences between the training and the testing data set, and show function shows the plot. If you see, the training and the testing accuracy is almost the same, which is at the higher level. So it is around some 91%. That means you can see what I told you, overfitting problem indicates that the training performs well, testing doesn't perform well. But here, the training is performing well, testing is also performing well. That means there is no problem of overfitting or underfitting. Correct. No, by the graph, you can identify whether the model is overfitting or underfitting. Very simple to understand also. Just by, the model what you have built, plot it on the graph, right? So the model what you have built, just plot it on the graph. And, it's been shared, Aish. You can just check the attendance. Sushmita ma'am, you can just share the attendance link again. Some people are asking. Okay.
Yeah, sure, sir.
Yeah. So, you can easily plot it, and just, few lines of code, you can plot it. Okay. So you don't even need this X label, Y labels, nothing. If you want, you can give, or, you can show the legend also or not also. So just small function of plotting the graph for the training and the validation. Now, what happens is it will show whether the data is overfitting or underfitting. Okay, so now we also plot the loss function. Okay, so loss function should be as less as possible. This is for comparison of the training as well as the validation accuracy. So now we'll go with the loss function. So loss function also together it should be very less, right? So if you see the graph again, the loss function is also at the lower level. So it's around some 20%. So that is also fine, because since the model accuracy is good for training and both testing, the loss function, it should be at as less as possible. Because see, loss, what is loss? We have already discussed. What is loss exactly? Differences between the actual and the predicted value. So you want difference between the actual and predicted value to be more, or you want the actual versus actual minus predicted value to be less? It should be less, no? See, what we are predicting and what is actual value, it should be very less. Why? Because it should be close by. So if they are close by, they are close to each other, we will not have much of difference. So if there is no much of difference, we will not get more, more difference between the training and the validation data set. So we will have a very less difference between them. So that means they are performing well. There is no much difference between both training and validation. So it is performing well. So that means our loss function should be minimum. This is the logic behind understanding the loss function. Now coming down, we try to build the report. Okay, so that report will be inside the function accuracy score, accuracy underscore score. So now in this syntax or in this code what we have given, we have used the predicted function. So what we are predicting is two things. One is the testing variable for both, which is the X test and the Y test. Now, in this X test and Y test, we are giving the encoding. For example, if if that particular prediction is actually above that threshold value, predict it as the class 1, right? That means the prediction of what exactly is right or wrong. For example, here if you see one, this will actually help you to understand even better. For example, this is 0. You can see here 0, right? Forget about this results of categorical model and all. For time being, an easier way to understand is here you can see 0, correct? No? Here there is something called as a precision. Okay. So basically there is something called as accuracy and something called as precision and recall. Now, what exactly is this precision? Here you can see that something mentioned as precision. Okay, maybe I can put it here. Okay, I'll just take this sentence. It will be easy to understand. Just I paste it here. Yeah. Okay. This one is easy to understand now. Okay. See, basically the precision is nothing but the proportion of the positive predictions that were actually positive or actually correct. Okay. There's a difference between, accuracy and precision. The difference between accuracy is accuracy will be calculated only for the positive cases. Okay, but precision is calculated even for negative cases. Read the sentence carefully. The proportion of positive predictions that were actually correct. Best example is here in the data, we are predicting that a person doesn't have a heart disease, right? Let us assume there is one data point. We predicted as that the person doesn't have a heart disease. In reality also, he doesn't have the heart disease, right? Then it comes under precision. Why? Because it is a positive case which is actually predicted correctly. For example, if the person doesn't have heart attack, predicting that he doesn't have heart attack is a positive case. No, it's a correct thing what you have done, right? So that means in precision, you will have the cases which, or you can say the people who have heart attack or who doesn't have the heart attack also, which has been correctly. Yeah, spam email also. Yeah, this is also one example. Actually, we were discussing about healthcare, so I didn't take. So yeah. So for example, how this spam email, yeah, you can also think of, your Gmail account, which actually can predict the spam messages also, spam or ham. So spam is nothing but the, unwanted junk, and ham is nothing but the, genuine or the primary. Okay. So yeah, so you can also think of, spam and ham. Yeah, so I'll just give that example, Pratima. Okay. Okay. So yeah, so precision is nothing but predicting the correct values correctly. For example, when we are talking about these spam emails, so for example, there are emails which are genuine. Okay. So we built a model to predict. Usually for Gmail, it uses the naive Bayes algorithm. So for classification task. So for example, there are a genuine emails which are coming, which are sent to you. For example, some 10 emails have been sent. We have a model. Now that model checks, okay, so these 10 emails are genuine. So, and it sends that into your inbox because, the model is predicting that emails are genuine. Okay. So since they are genuine, it will send into your inbox. It will not send into your spam folder. Correct? No? Simple logic. Correct? Now, there are another 10 emails which are actually spam, right? So what is precision is? Precision is predicting the spam emails also as spam correctly. That means they are spam. So they are not supposed to be in the inbox. They are going into the spam folder. So this is basically predicting the true positive and the false positive cases. Okay. Yeah. So predicting the positive cases correctly is what the precision is about. Okay. Now, next thing is the recall. Okay. So now, one more thing is the recall. Now, after telling recall, don't get confused. Okay. So recall is nothing but the actual positive cases that were identified by the model. Okay. So now if you think that what is exactly recall? So recall is nothing but what the model actually predicted as positive. It might be a, for example, the model has predicted that that person is having a heart attack, because we are talking about positive cases now, correct? So that person is not having, so the person is having heart attack, but actually he doesn't, right? That doesn't come under recall. Why? Because recall is not bothered about what is, whether it is correct or not. Whether it predicted correctly or not, it will bother. Now, let us go to the, here, precision, it is predicted as 1. That means it predicted correctly for all the cases. For recall, it is 0.84. Okay, so that means there is a difference. And F1 score is basically the harmonic mean of, just, I think I've mentioned here also, I guess. Yeah, I'll just take this. Yeah. So F1 score is nothing but the harmonic mean of both the precision and recall. So this is basically F1 score is used for particularly the imbalanced data sets. Okay. So you can, you no need to remember, you no need to think too much about this macro average and all. That is not required. See this accuracy, what you got as 0.91, it will be mentioned here also. Okay. Now coming to the support. Support is nothing but how many observations are there which support this precision or which support this accuracy. 67 observations are there which are supporting this accuracy. That's it only. Support is just for how many are supporting or how many of them are voting. Okay. So that, and here this is for the 0 case. And for 1 case, which is the person having heart attack, this is what the precision is 83 and recall is 1 and 0.83, and this is 0.83 or 83%, or this is 1.0 or 100%. So how many are supporting is 29. So always remember this both cases, or how many cases are there. For example, if there are some 5 cases, so adding all the cases will come up to the support of what accuracy is actually giving. So this is what the classification report is about. Now going, let us pass, we have built a model here. Let us pass one data point. Okay, so let us pass one data point, and here we have in the data set, I think you already remember that we have the age, sex, smoker, years of smoking, LDL cholesterol and all. So we have to unseen data point we are actually giving in. Okay, so this model's accuracy is actually built on the data set what we are given. Now what we are trying to do is we are trying to pass one particular data point, and whether we are checking this data point is not in that 333 data set what we have trained. So we are passing some other data point which is unseen data point, and we want to check whether the model is able to predict correctly or not, whether that person will get heart attack or not. So here, if you see carefully, I have passed all the values here. So I've passed as a dictionary. Okay. So I have passed as a dictionary. It's the easiest way to do. Then we can convert it into a data frame. Okay. So now this is the data. Okay. So individual data I have passed. Now next step is converting into a data frame. So for converting into a data frame, the method what we use is the pandas. So pd.dataframe is what the unseen data point we are trying to convert. So now the same pre-processing step what we used for training, we are doing the same. So we are applying the unseen data's unseen underscore df minus the mean value and standard deviation value to to normalize the things. And then we are converting the data into an array. Okay. And then we use the model.predict function. So we apply this data or unseen data point, what we have actually given, to predict and to predict the probabilities. So argmax is nothing but argmax is used to predict the probabilities for the class labels. Now we will output the label, and we get the, here there is a small change. If you know the true label, you can give the true label, or if you don't know, you just want to know whether you will, if you have built this, okay, so you want to send your data and you want to check whether you will get heart disease or not. So then you are not knowing whether you are having or not, correct? Now to check this, you can, you need not pass this true variable or true label. So if you know that the true label, see here, if the true label for this unknown, for the unseen point is known. So if you know, you can pass. If you don't know, no need to pass. Okay. So here we are giving this particular function. So the predicted class is actually 1, right? It is predicting that you have heart attack. Okay. And the true label is also that the person is having a heart attack. So the accuracy will be 100%. Okay. So how it is predicting as, because when it calculated the probability was, I told you, it's all probability. So sir, in heart attack, to predict using probability, yes, we have to use probability. So the probability that this 0.2307696 is for the 0 class. So it predicted that 23% chance is there that that person is not having a heart attack or a heart disease. And here 62%, it is not summing up to 100. That means there is an uncertainty also. 62 and 23 is around some 65, 66% something, around 65.34 something. So around, around 85 point something. So around some 14-15% of uncertainty is there, whether the predicted class, whether the, the data what is passed, whether it is a whether he is not having heart attack or he is having heart attack. The model itself is in an uncertain position, because always remember our accuracy is 91% when we build the model. It's not 100%. Correct? No? So then there is an uncertainty also for the model. No, it will think that, oh my God, whether it is a class where it is a heart disease, whether that person is having heart disease or he's not having heart disease. So the model is not able to predict in that 14-15% what is there. But here, if you see, usually we take the value, probability value, which is more than 0.5 as a threshold value. Okay, so here you can see that 62.39%, the data point what you have sent, or the unseen data point what you have sent to check, it is predicting that 62% chance is there that this person has heart disease. That is why it is given as the it is more than 50%. So it is predicting that the person is having a heart disease. So, and the true label is also that the person is actually having. So if you know the true label, you can pass. If you don't know, you cannot pass. Anyway, you don't know, you cannot pass. If you have, you can pass. So this is what the project is about. So tomorrow we can see the credit card fraud detection. So anybody is having any doubt, you can ask me on the same what we have discussed. So I feel the project was interesting, and it was useful and good for you. So if you have anything, you can please ask me. Thank you for the response. Thank you so much for asking questions, because I'll be knowing that you are understanding or not, you have it's clear or not. So I should also know. So yeah, thank you. Thanks for asking questions from thank you from my side also. So anyone else, can I get link of what? Attendance. Okay. Okay. I think Chandana ma'am has shared. You can just give your feedback as well as the attendance. So anything else? Anybody? You can ask me. Thank you. Yeah, thank you also so much. Sure, in the LMS, would have shared. Sir, while doing prediction, how will we give minimum and maximum value? Yes, so this one actually I have explained when I have actually explaining the code. This minimum maximum is basically given on the predictions of on the assumption only. Because see, we always want the model to never go below some threshold value. So that threshold value it will calculate on its own based upon the model. That is why deep learning models are capable enough to they have even the auto function is also there. So you can actually give auto function and keep silent. The model will take care. See, the problem mostly comes when the accuracy. So thank you, sir. Explain the predict. You have explained the prediction model very nicely. Yeah, yeah. Thank you. So see, what happens is basically is the see. I'll tell you. Everything goes well when you have a good accuracy, precision, and recall. So yeah, all goes well, all are happy, all is well. Okay. So if that is not the case, right? If that is not the case, that the model has gone haywire, right? It is going in a maybe it is underfitting or overfitting or it is doing something other other things. Then we have to tune the model in such a way we have to make changes. That is where usually a data scientist spends a lot of time in tuning the model, because ultimately I told you also this sentence. So ultimately what we want, our model should have good accuracy, good precision and recall, so that when you pass an unseen data or a new data point, the prediction should happen correctly. Correct, no? So if I'm saying that a person with this kind of data should have heart attack, according to the data set, what it is trained upon, it should predict that correctly that fellow is having or not having. Correct? No, it should not, give a wrong prediction. Then your model is not good, right? Then what is the use of building a model, right? So that is the reason, it is very important for us to build a model. If the model is built correctly, fine. So how do you test? By passing on the data points, right, and checking whether the data is whether the data point is actually predicting correctly or or not. So that is in where data scientist spends his time in building a model, tuning the hyperparameters, identifying or doing the EDA process, and then optimizing the algorithms. And yeah, one more thing also, activation functions also, changing the activation functions on situations. So this is all part of process where we try to change different things to build a certain deep learning model. Deep learning technology itself is little tricky. So knowing the concepts and implementing in that particular project, building a model for prediction is what plays a very important role at the end. So that's where deep learning is prevailing actually in the current situations for all the AI applications. Sir, if accuracy and validation, sir, if accuracy and validation, accuracy difference more, is it an overfitting also? I didn't get your question. If the accuracy, so for training accuracy and validation accuracy, if it is both more, that means, for example, if the training accuracy is around some 90%, your validation accuracy is around some 40-50%, then it is an overfitting problem. Then it's an overfitting problem, because they should not have that much of difference between the there should not be that much of difference between the training and the validation, right? If they maybe some 1 or 2%, 3% is fine. For example, 90% is the validation, sorry, the training. And validation can be anything about 85, 86, 87, 88, 89, 90, 91, something like that is fine. But if it is goes drastically like 30, 40% and all, then it is an overfitting problem. Yes, correct. That's what you were asking. So it's an overfitting problem. Yes. So if both are down, that means both accuracy for training accuracy as well as the validation accuracy, both are down completely. Like, training accuracy is around some 30% or 20%, and testing is also some around 20, 30%, something like that. Then it is an underfitting problem. See, how you can say it is an underfitting problem is the model is not able to capture all the, all the features, right, or the patterns in the data. That is why it is not able to give you the accuracy, because it's not able to capture. In overfitting, what happens is the name itself tells you it overly captures, right? It overly captures the noise in the data. So it overly captures the noise in the data. It also captures which are required, which are not required, everything it will capture. That is in where we do the hyperparametric tuning. Okay, so that is in where we do the hyperparametric tuning and feature engineering to capture only the important features what are required, which are contributing directly to the outcome variable. This is what the entire scenario of machine learning and deep learning situation is. Thank you for deep explanation of deep learning. Yes, obviously the deep learning concepts are very deep, like the neural networks. There is a lot to learn actually. How much my experience with the deep learning, how much ever I have learned, I have built many models, I have built a lot of using models and using many data sets and all. Still, I feel there is a lot to learn on deep learning. It's like an ocean. It's like an ocean, and there's a lot to learn from deep learning, because the technology itself is very deep. Yeah, that is true. And it's a good technology which is helpful. See, at the end of the day, it should help us for doing the predictions. So it does that. So yeah, it's good. So at the end of the day, it's good. Okay. So anything else? Anything else? So my thank yous, I got thank you so much as well from my end. Any question I missed? I don't think so. This one explained. This one, thank you for explaining. Yeah, I think everybody have answered. Okay. So anything else? So if any new question if you have, you can keep it for tomorrow also, because tomorrow also we have a session, day 5. So for the day 5 session, you can come up with maybe first 5-10 minutes. We can have any doubts if you have, or we can straight away go into the project, because we have one more project also to discuss, which is on banking domain. So we have to do that also. So yeah, I think that's it from my end. Chandra ma'am, you can take over.
Yeah, thank you so much for wonderful explanation. You no ideas on that deep learning. Yeah, dear faculty members, I'm sharing the attendance link again. So if you missed out, please mark it. And any more questions, you can ask me here in the chat box. Okay. Questions? So yeah, we'll wind up the session for the day and we'll meet on tomorrow. Yeah, tomorrow is the last date. So yeah, Vijaya Petraj, yesterday I missed my attendance. Okay, like how many days you marked before? Like in 3 days, how many days you marked? Like 60% attendance is mandatory, means compulsory you have to mark 3 days attendance. Okay, based on calculate that, and yeah, if you reach 60%, you will receive the certificate or else some. We are sorry for that. Yeah. Okay. We'll meet on tomorrow. Yeah. Bye bye.